Our next trick for evaluating or finding limits algebraically, trick number 3, is to multiply by the conjugate. And this is really just another way to kind of carry along with our previous trick. This is another way to create a function g of x such that g of x is exactly identical to your original function f of x whenever x does not equal c. Okay, where c is the x value that you're trying to approach. Okay, so we had just looked at that idea, creating another function g of x to match your original f of x. And it was useful because of this property right here, all right? If you can find those two functions that are identical when x does not equal c, then as long as the limits exist, the limits of those two functions are going to be equal to each other. So if we can't find our limit on f of x originally, then we might be able to find the limit on g of x. Okay. So we're going to jump into an example here. All right, now we are going to be taking the limit as x approaches 0 of the square root of x squared plus 4 minus 2 over x squared. Okay, so one thing first, make sure your algebra is on point here. Do not try to say that the square root of x squared plus 4 is x plus 2. You cannot do that. That does not work. I'm going to write it down and be a little bit disgusted. Okay, this does not equal x plus 2. You cannot split a radical over addition like that. That does not work. Please, please, please don't do this. Oh no. That is one of my mathematical pet peeves, so be careful with that. You cannot split a radical over addition or subtraction. But what we can do here is we can find the conjugate of this numerator. Okay, and that is going to turn out to be useful because notice that, once again, we cannot direct substitute quite yet. We can't plug in x equals 0 because that would make our function undefined here. So can't do that. All right, and we can't factor and cancel on this one. So to take this aside here, the conjugate of the square root of x squared plus 4 minus 2, if you know what it is, that's good. Remember from algebra, the conjugate is that radical expression, but you change the sign in the middle, okay? So between the radical and the constant, or the first and second terms there, that minus right here turns to a plus. So it's the square root of x squared plus 4 plus 2. Okay, so what we are going to do here is we're going to multiply by that conjugate. Okay, so let me give us some room here. The limit as x approaches 0 of x squared plus 4 under our square root minus 2 over x squared. Okay. We are going to multiply that function by the conjugate of the numerator. But remember, if you do something in the numerator of a fraction or rational expression like this, you also have to do the exact same thing in the denominator. You got to keep it balanced. Okay, so when we do that, remember we still have to write limit as x approaches 0 because we're not plugging anything in yet. But if you multiply this out, you'll get the radicals to drop off of that first term, you'll get just x squared plus 4. And then the beauty of the conjugate is that the next two terms are going to cancel each other out. We're going to have plus 2 square root of x squared plus 4 minus 2 square root of x squared plus 4. So those two middle terms cancel each other right out. And that is really one of the main reasons why we learn about conjugates. Then the last terms, we multiply those and we'd have a minus 4. So again, that's just doing distribution like the FOIL process. However you would distribute that out. That's all we're doing there for the numerator. Then in the denominator, we have our x squared still, and we do have this additional rather clunky new factor down there that's multiplied in, but that's okay. We're just going to leave it down there in some parentheses for right now. Because look what happens. Up in the numerator, we have plus 4 and minus 4, so those are gone. And so we are taking the limit as x approaches 0 of now x squared over x squared times our conjugate factor. And you'll notice that I didn't distribute the denominator there. And this was why, because now the x squareds are going to cancel right out for us. And that's great, because now we are just taking the limit as x approaches 0 of 1, remember there's still a 1 up in the numerator, over our conjugate factor there. Okay, so 1 over the square root of x squared plus 4 plus 2. And at this stage, since we've gotten rid of that x squared factor down in the denominator, we can actually plug in x equals 0 at this stage. So this has created a new function, g of x, that's identical to our original f of x up here. Okay, so if you were to graph these two, they would look exactly the same, except where x equals 0, all right? So g of x actually equals f of x when x doesn't equal 0. All right, everywhere except at that point, they're the same. But yeah, we can do direct substitution now. We can plug in x equals 0. Substitute x equals 0. And that is very nice. So you get to stop writing limit at this stage. Remember, when you substitute, you get to stop writing LIM x approaching 0. And we just get to do 1 over, that would be 0 squared plus 4 under our square root, plus 2. And then we simplify that down. We would get 1 over 2 plus 2, and that's 1/4. And that is the limit of our function. So that's our final answer here. Okay, so that's how you use a conjugate and multiplying by the conjugate to help you find a limit algebraically.